Hello guys, welcome back to CP Fundamentals. And today we're gonna learn something really useful in competitive programming, which is the sorting techniques. So first, today's lesson is gonna be about sorting methods and then the library sorting. So I just had a really interesting picture here uh, representing all of the sorting algorithms from quicksort to cubesort. But normally we usually use quicksort, merge sort, and sometimes when we first learn the sorting techniques, we're gonna learn bubble sort and selection sort. Okay, so first we go to the sorting theory. So sorting is a fundamental algorithm design problem, and many efficient algorithms use sorting as a subroutine because it is often easier to process data if the elements are in a sorted order. So uh, this means that when you encounter a problem on any online judges or any competitive programming competitions, you will notice that some problems require us to sort our array or sort something because it will help us to get close to the correct solution. So for example, the problem, does an array contain two equal elements, is easy to solve using sorting. So if the array contains two equal elements, they will be next to each other after sorting whenever it is decreasing or increasing, and it is easy to find them. And also, the problem, what is the most frequent element in an array, can be solved similarly by sorting too. And there are many algorithms for sorting, and they are also good examples of how to apply different algorithm design techniques. And the efficient general sorting algorithms work in a O n log n time, and many algorithms use sorting as a subroutine also have this time complexity. And next, we gonna go through three most popular sorting techniques. So the first one is bubble sort, and a classic sorting algorithm. So this is a O n squared algorithm that consists of two nested loops. Bubble sort has n rounds. On each round, the algorithm iterates through the elements of the array. Whenever two consecutive are found that not in correct order, the algorithm swaps them. And after the first round of the algorithm, the largest element will be in the correct position. And in general, after k rounds, the k largest elements will be in the correct positions. Thus, after n rounds, the whole array will be sorted. So this is the implementation of bubble sort. We're going to start with uh, from the index 0 to index, and we're going to look through 0 to n minus 1. And then we have another for loop, iterates through the indexes from 0 to n minus 2. And then we're going to swap two consecutive elements if they satisfy these requirements here. So HA is greater than HA plus 1, which means we swap the greater value uh, uh, into the right side and a smaller value into the left one. An extra thing here when I code the bubble sort. Um, Back when I was in uh, secondary schools, I learned selection sort, but I was mistaken it from the bubble sort. I I did think that this is the bubble sort because they are all the O n squared algorithm sorting algorithm. And but the difference here is that we're gonna uh, compare two consecutive elements with the first one start from I equals to 0 to from 0 to n minus 1, and the next one will start right next to the first element, which is I plus 1 to the n minus 2, and then uh, depends on it depends on the conditionals here, the conditions here, which is either AI is smaller than AJ or in the below AI is greater than AG. We swap them and it will give us uh, the so the first one is going to be the decreasing array and the second one will give us the increasing array respectively. Next we move to merge sort. So this is the most commonly used sorting algorithms, because uh, as they say, as it is said here, it is possible to sort an array efficiently in O n log n time using algorithms that are not limited to swapping consecutive elements. And merge sort is based on recursion. So we're gonna sort a subarray from A to B as follows. So if A equals to B, do not do anything because the subarray is already sorted. And we calculate the position of the middle element, which is K equals to lower bound of the sum of A and B divided by 2. Then we recursively sort um, the first subarray from A to K. And then we also do the same thing with the subarray from K plus 1 to B. So basically we just divided our array into two subarrays. Then we sort them in a specific order, and then we merge them together after sorted. Because uh, here they say that because merge sorts have the size of the subarray at each step, so the recursion consists of O log n levels, and processing each level takes O n time. And of course, you can see that merging the subarrays is possible in linear time because they are already sorted. So this will give us the merge sort algorithm with the O n log n time. So this is the how we do the merge sort manually. First, we divided this array, the following array, into two subarrays as follows. Then we sort the first one and then the second one. After that, we can merge them together into the final sorted array here. The next one is counting sort. So this is a less commonly used algorithm in my opinion because I hardly use can we sort in real life competitive programming problems. So we'll see that can sort states the lower bound and log n does not apply to algorithms that do not compare array elements but use some other information. And an example of such algorithm is carry sort that sorts an array in O n time, assuming that every element in the array is an integer between 0 and c is equals to O n. And this algorithm creates a bookkeeping array whose indexes are elements of the original array. The algorithm iterates through the original array and calculates how many times each element appears in the array. So the first one, we have this array, and uh, this is going to be the corresponding bookkeeping array. So we can see that element 1 appears one time, 2 appears 0 times, 3 appears 2 times, 4 0 times, 5 1 time, 6 1 time 2, 7 uh, does not exist, 8 does not exist too, and 9 appears 3 times. And construction of the bookkeeping array takes O n time. And after this, the sorted array can be created in O n time because the number of occurrences of each element can be retrieved from the bookkeeping array. Therefore, carrying sort has the complexity is O n. Carrying sort is a very efficient algorithm, but it can only be used when the constant c is small enough so that the array elements can be used as indexes in the bookkeeping array. Next, we move to library sorting. Previously, I just told you about three famous uh, sorting algorithms, but in a CP context, it is not a good idea to use a homemade sorting algorithm because there are good implementations available in programming language. For instance, the C++ standard library contains the function sort that can be easily used for sorting arrays and other data structures. Uh, the benefits of using a library function is firstly, it saves time because there's no need to implement the function. Second, the library implementation is certainly correct and efficient, and therefore it will a homemade sorting function would probably not be better than the built-in sort function. And in this section, we will see how to use the C++ sort function. So first one, we apply standard library sort function into static arrays. To sort static arrays, you sort name and the name of the arrays and plus the number n, which is the number of elements to be sorted. The range can also be specified by replacing this with the intended range. For example, like sort the name of the array plus one, the name of the array plus four, which means we sort the array sorts the indexes 1, 2, 3. Next, we move to dynamic arrays. Uh, in order to sort a dynamic array, we use a different uh, approach here. We have to use, we still use the sort function, but we have to use dot begin and dot end because uh, because the vector, this is the correct way to sort a vector, which is also a dynamic array. Similarly, like static arrays, we can specify the range. Uh, and also the pairs, arrays of pairs and tuples and other stuff will have the same syntax as the uh, dynamic array sort function. And that's it for today. Thank you for listening to introduction to sorting. If you think this video are useful, you can visit YouTube channel CP Fundamentals to reach out other competitive programming videos, which I also uh, uh, code the solution for different CP problems from various online churches.